Hello students, my name is Mahesh Mahale, working as assistant professor in S.V.K.T, Arts, Commerce and Science College, Devlali Camp, Nashik. So in this lecture, we will discuss the part of ionic solid, that is from TYBSc classroom, the crystal structure or crystallography. In this session, we will discuss what are solids, crystal structures, then crystal lattice and types of cubic crystals. So learning objectives will be how the solids are divided into crystal lattice, what is unit cell, and what are 7 types of crystal system. So classification of solid. So solids are generally classified into two classes, that is crystalline solid and amorphous solid. So based on their arrangement of atoms, ions and molecules in their framework, they are classified into crystalline, amorphous solid as shown in figure. So in crystalline solid, the atoms, ions or molecule are arranged in orderly manner, whereas in amorphous solid they do not arranged in orderly manner. So this is the basic classification or differences between the crystalline solid and amorphous solid. So crystalline solids are basically, the crystalline solid have a definite characteristic shape, so they do possesses a perfect shape. So in amorphous solid they do not shows a perfect shape or irregular shape. So they have, crystalline solids have regular arrangement of constituent particle, that is ions, molecules or atoms are arranged in a regular arrangement, whereas in amorphous solid they do not arranged in a regular arrangement. So in crystalline solid they have a sharp characteristics melting point, so they melt at a sharp temperature, whereas amorphous solids show a range of temperature where they melt, so they do not have a sharp melting point. Crystalline solid, when cut in a with a sharp edge tool, they split into two pieces. So the newly generated surface have a plain and smooth surfaces, whereas in amorphous solid, when they cut with a sharp edge tool, they cut into two pieces with irregular surfaces. So as they do not have a orderly arrangement of atoms, ions or molecule, so they do not show a plain or smooth surfaces. So examples of crystalline solids are basically copper, silver and other metal. And in compounds, so sugar is the best examples of crystalline solid, whereas NaCl is the best example of amorphous solid. Crystalline solid. And amorphous solid show amorphous solid, examples of amorphous solids are basically rubber, glass, plastic, etc. So in a crystalline solid, the atoms vibrate in a plane in a fixed pattern. So in amorphous solid, atom vibrate in a plane more than a random arrangement. So they, due to the arrangement, so they show a different vibration patterns in them. So unit cell, the smallest repeating unit of a crystal structure in a 3D, which shows a full symmetry of a structure, it is called as a unit cell. So unit cell is basically a smallest part of that crystal structure which represents whole crystal structure. So there are 7 types of unit cell or 7 types of shape of unit cell, and these shapes are further classified into 14 Bravais lattices. So August Bravais was the scientist who was a mathematician who classified these types of 7 crystals into 14 Bravais lattices. So this is the general representation of unit cell. So in that, the crystal structure, so this is the big crystal structure, this is actually a crystal structure of NaCl solid. So this crystal structure is actually showing that the repeating units of each unit cell is repeated many times. So at that side figure in right side, so there is a representation of that unit cell. So in a unit cell, the edges are represented by A, B, C, whereas angles between them are represented by alpha, beta and gamma. So they were shown in a green, and the black ABC represents the edges. So A represents edge, where B represents length and C represents heights of that unit cell. So this is the basic unit cell representation of unit cell. So in general, when unit cells are placed or unit cells are classified into are further classified, these are the basic models of unit cells. So this is the cubic unit cell, simple cubic unit cell, showing that the 8 atoms, the marks in red, 8 atoms are at edges of that, so corners of that unit cell. This is the FCC type of unit cell, whereas in FCC, so this blue color atom is at the center of that unit cell and 8 atoms are at the corner of that unit cell. And this is the FCC structure of cubic crystal, wherein the red atoms are at the corner, whereas the blue atoms are at the faces of that unit cell. So total 8 atoms are at the corner and 6 atoms, so as cube having a 6 faces, so 6 atoms are at each faces. So that center atom in front of you has a backside, there is also a backside atom that behind that center atom. So 7 crystal structures are classified or are are classified or separated by axis, whereas in angles. So these are the 7 crystals system, which is triclinic, monoclinic, orthorhombic, tetragonal, cubic, hexagonal and trigonal. So the difference between these crystal structures from each other are basically the axis and the angle. So in a triclinic, so there is alpha, beta and gamma. So angles are represented by alpha, beta and gamma. So alpha is not equal to beta is not equal to gamma, which is not equal to 90 degrees. So all angles are different and all angles are not in 90 degree, whereas axes are also not same. So A is not equal to B is not equal to C. So all axes are different in sizes. So second crystal system is monoclinic. So in monoclinic, alpha is equal to gamma, which is equal to 90 degree, whereas beta is not equal to alpha and gamma, which is not equal to 90 degree. So axes are also different. So A is not equal to B is not equal to C. So third crystal system is orthorhombic. So in orthorhombic, all angles are 90 degree, that is alpha is equal to beta is equal to gamma, whereas all axes are different. So A is not equal to B is not equal to C. In tetragonal system all angles are equal to 90 degree and A is equal to B, whereas B is not equal to C. In cubic system alpha, beta and gamma all angles are 90 degree, whereas axes are also same. So edge length of A and B and C are equals. In hexagonal system alpha and beta both angles are 90 degree, whereas gamma is 120 degrees, 120, and axes are A is equal to B, where B is not equal to C. In trigonal system, alpha is equal to beta, which is 90 degree, whereas gamma is also equal to 120 degree, but axis or A is equal to B, which is not equal to C. So these are some diagrammatic representation of 7 crystal system. So these 7 crystal systems are further classified into 14 Bravas lattices. So these 14 Bravas lattices are shown in figure. So cubic system is further classified into 3 classes, whereas primitive, body center and face center. So primitives are basically shown in blue color, body center are shown in green color, whereas face center are shown in red color in cubic crystal. So in cubic crystal, this is a primitive cell, then a body center, then a face center. So in primitive, the 8 corners contain 8 atoms, whereas in body center, the center position of that atom is occupied by an atom, whereas 8 atoms are present at each corner. So there are 8 atoms at the corner and 1 atom at the body center. And in face center, so 6 atoms are at the faces, whereas 8 atoms are at the corner of the edges. So in tetragonal system is further classified into 2 types, which is primitive and body center. Orthorhombic system are classified into 4 types, whereas primitive, body center, face center and end-to-end center. Hexagonal system are of 2 types. So primitive, hexagonal system is of only one type, which is primitive. Tetragonal is also a one type, which is primitive. Monoclinic also have 2 types, which is primitive and end-to-end center, whereas triclinic has only one only one classification, which is primitive type. So these are the 14 Bravas lattices. So each Bravas lattices is different from each other. So cubic crystal, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic and tetragonal system. So these are different types of 7 crystal system and further classified into 14 Bravas lattices based on their arrangement of atom in that unit cell. So in this lecture we have discussed the repeating unit of crystal structure is called as unit cell, whereas simple cubic contain one atom at the center, whereas BCC contain 2 atoms and FCC contain 4 atoms. So in that slide we have discussed that the primitive cubic crystal have a one atom in whole, that is a 1/8 the part of each atom is in the cube. So 1/8 into 8, so 8 atoms are present at each corner. So 1/8 into 8, which is equal to 1 atom. So primitive cells contain 1 atom in whole, whereas body center contains 2 atom in whole, whereas face center contains 4 atoms in whole in that unit cell. So we have discussed in all these in this lecture. So as assignment for you is how many number of atoms are in FCC and BCC structure. So what is isotropy and anisotropy, what is the definition of unit cell, which is the most ordered system, and which is the most asymmetric system in crystal lattice. So we will see you in a next lecture.